students. Right, so you're back in school. I'm still here on your screen. Yeah, we're gonna talk about how we're gonna do it. Look, we're gonna carry on with this video recordings of the lesson. Definitely for those who are not back here yet. But actually, I want to carry on recording lessons. So I think it's just in my mind. I can just envision a library, a library of video lessons of maths. Maths AP, but I'm actually doing it also for your normal maths. So I'm starting right now with my grade 10. And I go, so in my mind, Woodbridge can have a library of all the maths lessons from grade 10 to 12 and AP as well. So whenever you want to revise something or you're not sure about something, or maybe you went on tour for a week and you miss your maths lesson, you can just go onto that library and catch up with Trig or whatever you missed. So I'm going to carry on recording these lessons. But I know that some of you wanted to, also see me and have a normal lesson that in front of me. So first of all, as I said, on Wednesdays after school, this is like your private clinic. Any problem, you come to me and we'll work on questions together. Okay, so we're not going to have live lessons. We're going to have real live lessons. My class on Wednesdays. But if you want to also, instead of watching these video lessons, you want to watch me live, then come to me. Okay, talk to me, and I'll arrange that time to do with you. Currently, I do it in the mornings. But if you really just want to be there and see me and do that lesson together with me live, then just let me know and I'll make sure I'll make a plan with you, okay? I can do these video recording whilst you're sitting in the class. There's no problem, okay? Right, so we are really starting calculus this week. And we start with, the first lesson is a short lesson about average gradient, and then we're going to go into instantaneous gradient, okay? So imagine we have a function, okay? Blue fx, okay? Blue curve, and it goes through these 2 points. Now let's say I want to find out the average rate of change, okay? The average rate of change or the average gradient between these points A and B. So what do? I just connect these two A and B in a straight line, okay? I'm sure you've seen that before. You make this right angle triangle. We call that sometimes delta y and this sometimes delta x, isn't it? We say that A, we have x1, y1, and these are the coordinates of A, and the coordinates in B is x2, y2, and we say that the average gradient is, which is delta y over delta x. I'm just going to write this in different ways, so okay, it's familiar in some way. So it's y2 minus y1, x2 minus x1, right? Delta is difference. So it's a difference in the y divided by a difference in the x. Okay, I'm sure you've seen that before. Now, I'm just going to write it in a slightly different way. Instead of writing the y's, okay, what is the y? Because we're dealing with a function, okay? Y is f of x, right? So y2 is also f of x2, okay? The y coordinate at B is simply f of x2. Put x2 inside the f and you get the y. Okay? And in the same way, y1 is f of x1. Okay? So we can also write it as f of x2 minus f of x1 divided by x2 minus x1. Okay? And that's how we calculate the gradient, or average gradient, or average rate of change. Okay? Now, if obviously I can't calculate anything because I don't know what is f of x, but if I give us now a function, then we can calculate the gradient. So let's do that, okay? Just pause you here for a second. Right, so the first exercise 5.1, they're giving us a certain function. F of x is x squared minus 2x. And we want to find out the average gradient, okay, between the points x equal minus 1 and x equal minus 3. So these 2 points, the x's are minus 1 and minus 3. And then we want to find the average gradient. Okay, so it's just going to be f of x2. Okay, so we need to kind of figure out which one is the x1 and which one is the x2. In fact, it doesn't really matter. Okay? It doesn't really matter because if I choose this one to be x1, this one to be x2, I'm going to swap these two around. I'm going to swap these two around. So you're going to get the same. You're going to get the same answer. But I think, I don't know. I kind of used to always have x1 smaller than x2. Okay? I kind of work it like that. Okay, so because I want to deal with positive in the denominator, so x2 minus x1, I always want it to be a positive number. So I always take x1 to be smaller than x2. So the x1 is the one on the left, the x2 is the on the right. If you did it the other way around, it's going to work out exactly the same. Because you might get a minus here, but you'll get a minus there. It will cancel each other out. Right, so I will go with minus 3 is smaller than minus 1. So x2 is minus 3. So f of minus 3 minus f of minus 1. Okay, this is the difference in the f's, right? I'm calculating the average gradient. Okay, so f of x2 minus f of x1, f of minus 3 minus f of minus 1 equal minus 3 minus minus 1. Okay, you've got to watch out when you have negative x's, so you need to have the two minuses. Okay, now hopefully now you understand what I'm saying. If I chose minus 1 and minus 3 to be the other way around, if I did it, let's say I said f of minus 1 minus f of minus 3 divided by minus 1 minus minus 3. Okay, if I chose x1 and x2 to be the other way around, you will get the same thing. Okay? I don't know if you can see it, you will get exactly the same thing. Because I swapped the denominator, but I swapped the numerator. Okay? Right, now we need, because we know we have a specific f, okay? So we need to substitute in that, okay? So I'll put minus 3 squared minus 2 times minus 3. I'm just substituting instead of x, I'm putting minus 3 minus, and now I substitute instead of x, I substitute minus 1. So, and I must make all in brackets, okay? So, minus 1 squared minus 2 times minus 1, okay? So, that's the f of minus 3 minus the f of minus 1 divided by minus 3 minus minus 1 is minus 3 plus 1, so divided by minus 2. You guys can still see it. Okay, and then we just need to figure out, okay? So that's 9 plus 6 minus 1 plus 2. Okay, please check me if I've got something wrong here. Okay, hopefully nothing wrong. Okay, 9 plus 6 is 15 minus 3 is 12, right? 15 minus 3 is 12, divided by minus 2 minus 6. Okay, so the average gradient is minus 6. Okay, so obviously that picture is not very good because the gradient here is positive, here we have a negative. But obviously that's just a random picture. That's not really this function. Okay, so what was the answer? The average gradient between x equal minus 1 and minus 3 is minus 6. Okay, now one thing, and I'm just going to finish it here. Okay, we can definitely see that the average gradient gives you some kind of idea of the steepness of the slope. Okay, but it's not the accurate one because it's just average. Okay, obviously if I chose different points, if I chose, let's say, these 2 points, then I'm going to get a different steepness. See, here in this graph, the average between those two is that gradient. If I choose these 2 points, I'll get a different gradient, which is actually smaller. So if I want to know what is the true gradient, the true steepness in a point, okay, it makes sense that I need to bring that other point closer and closer to the first point. I need to bring x1 and x2 closer and closer together. But there's some real issues there, okay? And we're going to find them out in the next lesson.